Now we're going to talk about partial fractions. So we have two problems today. And the first one, we are asked to write the partial fraction decomposition of the fraction 5 over x squared plus x minus 6. Now, the first step for our solution would be to separate this into its factors. The denominator will be factored. So, to do that, we resolve this by separating it into two terms, one for each factor of the denominator. So we have here, if we factor out the denominator, we have x plus 3 times the quantity x minus 2. So the first term will be a, the first factor will be represented by a over x plus 3, and the second one will be b times the second factor x minus 2. So as we are now solving this into two factors, we multiply the equation by the LCD. The LCD is x plus 3 and x minus 2. These are two factors here. After getting this LCD here, after multiplying, we get 5 is equal to a times quantity x minus 2 plus b times quantity x plus 3. Now, as you can see, to solve for each variable, we must get rid of the first variable by assigning a value for x, which will make this the first or the second term resolved by 0. Take means 0. So we set x is equal to 2. Doing that, we cancel out a, since 2 minus 2 is 0. And what remains is b times quantity x plus 3. So we multiply b times 2 plus 3. 2 plus 3 is equal to 5. So we have here 5b is equal to 5. So getting the value of b is equal to 1. So after which you can now set x is equal to negative 3, to get rid of b, So after assigning x is equal to negative b, we get 5 is equal to a times quantity negative 3, since x is equal to negative 3, minus 2. So negative 5a is equal to 5, and a therefore will become negative 1. So we get two values for our two terms. A will be negative 1 and b is equal to 1. So the partial fraction, the decomposition of this problem here, 5 over x squared plus x minus 6 is equal to, the value of a is negative 1 times the quantity over x plus 3, and the value of b is equal to 1 times over x minus 2. So we interchange, so get to make this second term negative, so the final answer is equal to 1 over x minus 2 minus 1 over x plus 3. So we go to our second problem. The second problem will be, we are asked to resolve into partial fractions the fraction 5x minus 2 over 6x cubed minus 5x squared plus x. Since this is qubits, we can factor out this by factoring out x, so 5x minus 2, and then after factor out x, we get 6x squared minus 5x plus 1. And then we still factor this 6x squared minus 5x plus 1 by 3x minus 1 and 2x minus 1. So we have 3 factors for the denominator, and so we're going to, since these 3 are linear, we simply get the 3 terms and assign each term by variable a over x, no? The first factor, the first term will be a over x. The second factor will be b over 3x minus 1. And the third term is c over 2x minus 1. So we get the LCD, multiply the whole equation by this LCD x times quantity 3x minus 1 and 2x minus 1. After multiplying the whole equation here by the LCD, we get now 5x minus 2 is equal to, since we cancel out x, what remains is a times quantity 3x minus 1 times quantity 2x minus 1. For b, we cancel out 3x minus 1, we get bx times quantity 2x minus 1. And for c, we cancel out 2x minus 1, this one we cancel out. So what remains is cx times the quantity 3x minus 1. So we get this new equation. So to get its value of the variable, we set x so as to make its variable 0, no? Whatever variable it is. So if we assign x is equal to 1/2, we cancel out a, and we cancel out b, since this factor here becomes 0 and this factor here becomes 0. And what remains is cx 3x minus 1. So we have here 5 times the quantity 1/2, minus 2, 5, this one is 1/2, no? We said this one 1/2. 5 times quantity 1/2 minus 2 is equal to c, this c here, no? And x is 1/2, so times the bracket that 3 times 1/2 minus 1, no? So this one is 3. So this one is 5 minus 4, the LCD of this part here, the left side of the equation. 5 minus 4 over 2 is equal to c over 2 times this one is 3 minus 2, no? That one becomes 1/2, no? So since this is 1/2, 5 minus 1 over 2 is equal to c over 4. So the value of c will be 2, no? Since we multiply the whole equation by 4, we get c is equal to 2. So to continue, since we have already found the value of c, we look for the value of a and b, no? So we set x is equal to 1/3 so as to get rid of a, no? So doing that, and also c, no? So what remains is, if we set x is equal to 1/3, so 5x minus 2, so x is 1/3 minus 2, what remains is b, x is 1/3, and this 2 times 1/3 is 2/3 minus 1. So this one becomes 5 minus 6, no? So we work out on this portion here. 5 minus 6 over 3 is equal to, so this one is 2/3 minus 3 over 3, negative 1/3. So this one becomes 1/9, negative 1/9 b. And to get the value of b, we multiply the whole equation by 9. So b is equal to, since this also is equal to negative 1/3, and then negative, so the value of b will become, b is equal to 3, since we multiply both the whole equation by 9, no? Or negative 9. So now, we have the two values now for our two variables, for c, which is equal to 2, and b is equal to 3. So we are now ready to get the value of a by setting, no? X is equal to 0. If we set x is equal to 0 here, we're getting rid of the variable c, b and c, no? B and c, no? So this portion here becomes 0. What remains is this portion here, no? So we set a, we set x is equal to 0. So 5 times 0 is 0. Minus 2 is equal to a, since x is equal to 0, negative 1. And 2 times 0 is 0, minus 1, so negative negative is positive. So a will become negative 2. Now, the value of a is equal to negative 2, and b is equal to 3, and c is, as we have found, c is equal to 2. No? So our answer will now be the partial fraction decomposition of this problem here, 5x minus 2 is equal to x, all over x times quantity 3x minus 1 times quantity 2x minus 1 is equal to negative 2 over x plus 3 times quantity times all over 3x minus 1 plus 2 over 2x minus 1. So that's it. That's how we're going to make the partial fraction decomposition of the given fraction. So thank you for watching again your tutor Willie for discussing these partial fractions, and be sure to subscribe and click that notification bell. No? So if you have any suggestions, please send us your suggestions and comments so as we can improve our presentation. So thank you, and see you again later.